everybody, and welcome to Mindset Learn Extra. Thanking you for joining us live on our studio. It is channel 319. My name is Pumi, and joining us in studio today, it is Tracy. Hello, Tracy.
Hello, Pumi. How are you?
I'm good, thanks. How are you doing?
Good. It's a good place to be in the holidays, hey?
Yeah, it is, hey?
Wonderful. Well done for being here. I mean,
Yeah.
my platform's squeaking, but that's okay.
Yeah.
Anyway, yes.
Anyway, we also have our mindsetter in studio today. It is Sfiso. Hello, Sfiso.
Hello, Tracy. Hello, Pumi. Hello, Mindsetters. My name is Fiso from Spukeng in Zone 7, and I'm representing SOA Secondary School. I'm doing chemistry, not that good at it, but I'm sure Tracy will be helping me too much.
We're going to try. I'm sure it's not as bad as you think.
Not really, yeah, but I'll try.
All right, then, Mindsetters, I'm sure that you also would love to see Tracy helping you out with organic chemistry today. Please do join us on our page. It is mindset.co.za/learn/winter school. You can always get our notes right over there. I mean, we are working on the notes the notes that we have on the page are the very same notes that we will be focusing on today. So please join us live right here on Mindset Learn Extra. One other interesting thing that we have for you guys at home is this competition sponsored by Soul Candy. Now, guys, this is what you have to do so that you can get this nice DVD. Okay, we are giving away. Okay, I'll tell you a little bit later what we are giving away, but it's one of these CDs right over here. So, guys, this is what you have to do. Jump on to mindset.co.za/learn/stop the clock. That is the name of the competition. You will have to choose any number between 0 and 9, and then you'll have this nice little form that you have to fill in where you can keep your guesses in it. But right now, guys, let's just get straight to learning and join us until we're done.
Okay, my turn. I think that's what Pumi was trying to say to me. Anyway, okay, so it's my turn, all right? And it's a very cool competition to make sure you get there. It's a good guess as to how many likes we have. Now, what we're going to do today is we're going to do organic chemistry. So the whole of today's lesson is focused on organic chemistry, which, yeah, if you like we saw, not so cool. Yeah. But yeah, it's okay.
I'll be right.
You'll be okay.
Right, yeah.
Cool. All right. Guys, the thing with organic chemistry is it's quite a big section in your exam. It can be up to 50 marks out of 150 in your chemistry, so it's a really important section. The nice thing is that all the questions are tending to be the same. So you can guarantee that you're going to get things like naming, drawing, isomers, and trends. The big thing with boiling point, melting point, all of those things, which, yeah, we know it, but they're all the same. So what we're going to do is we're going to go through the sort of questions you can get. We're going to start with the one-word answers. The nice thing about the one-word answers is they tend to be more theory. So let's start with those. Okay. And the first thing they say, and remember with one word or term, it's exactly that. It can be a term or a single word. And they say to you, the first one is, an atom or group of atoms that gives an organic compound its chemical properties. What would that be, Sufficient?
Homologous series.
Almost. That's the name of the general series. But
okay.
what is it that makes it say, what makes an alcohol an alcohol?
Functional group.
The functional group. So that's what they want, the functional group. If they wanted a homologous series, I hate that word, by the way, they would have asked for, the definition is a group of chemicals that have the same properties. Okay, that would be, but this is because they want the atoms that give its function.
Well, I would correct if I say it's the group of atoms with the same formula.
General formula.
General
Yes,
formula.
you would be. Absolutely. Correct.
Okay.
Now, 1.2, the type. Now, guys, this is where we get it becomes a little bit hairy in normal questions, because it says type of addition reaction where hydrogen halide is added to an alkene. Remember, if I just asked you for the type of reaction where a hydrogen halide is added to an alkene, we could just call it addition. Okay?
Yeah.
But now they want the full name
Yeah.
for the type of addition, not those horrible long names. So
Yeah.
what would we call this one?
I said it's a hydrohaloalkene.
That's the type of compound we get when we're done.
Okay.
But now, if it's a type of addition, so then it would be the it's hydrohalogenation.
Oh, okay.
Yeah. So it's horrible words like halogenation, hydration, hydrogenation. The type of compound formed is would be a haloalkane. alkene in this case.
Okay.
No, it's added to an alkene, so it would actually turn it into an alkane
Okay.
because it's addition.
Yeah.
Okay, because it would break the bonds.
Yeah.
Okay. This is a nice one. Type of alcohol.
Oh, I struggled with this one.
Yeah, it's fine. First, remember we've got primary, secondary, tertiary
Yes,
alcohols,
yes,
right?
yeah.
So first thing we need to remember is where's the double bond oxygen in an aldehyde?
Like I said, it's a secondary alcohol, so it's in the second carbon.
Because you think it's going to be in the second one.
Yeah.
But an aldehyde is actually defined by having it
Yes.
at the end.
Oh, so it's primary.
So you thought it was a ketone.
Yeah.
So no, it's fine. I like the thought process was correct.
Okay.
Because you thought it was a ketone, so then it would either be a secondary or it could have been a tertiary.
Yeah.
Okay, so it could have been either because it could be on the second or in the middle. Whereas they are specifically an aldehyde because there's only one option, which would make it a primary.
Primary.
Yeah. And I know, I still have to think twice about where the aldehyde and the ketone sit.
Yeah, same.
Yeah. The way to think about it is formaldehyde. You've heard of formaldehyde, hey?
Yeah.
That's what they used to preserve things for when things are dead. So when it's at the end of the chain, it's dead.
Nice.
So it's one way to think of it. I'm not
Nice.
sure it really works like that, and I'm probably going to get shot by somebody along the way, but it's okay. Anyway, there we go. Now, the series that has the carbonyl group in the middle,
Ester.
almost.
Esterification.
No. You're on the right track. You just got
Okay.
confused between carbonyl and carboxyl.
Carboxyl.
Esters are carboxyl
Okay.
because you're thinking of the double bond oxygen and the OH
Okay,
and the O
yeah.
in the middle, so you would be right. But the carbonyl is actually this one.
Oh.
So now, if the aldehyde had it at the end, which one would have it in the middle?
Sorry.
If the aldehyde has it at the end, the double
Okay.
bond oxygen, which one? Because we just spoke about them just now. This would be a ketone.
Ketone.
Yeah. Okay.
Okay. Yeah.
You okay with that?
Yeah.
All right. All right. Then this one's nice. This is a nice because it's definition. Molecules that have the same molecular formula but different structural formula.
Structural isomass.
There we go. Isomers. Absolutely. And this Penny's just having a whole moment. I just thought I'd share that with you. Okay. Anyway, the board doesn't like me, just in case you didn't know. Okay, so those are isomers. Those are definitions. So,
Yeah.
so we're okay with that. Okay. Now, after your one-word answer, I hate this earpiece, just so you know. We would then have to go on to the multiple choice. Now, what we're going to do, guys, is I'm not going to do the multiple choice with you right now because I want you to go to Curio. Now, some of you have already registered on your phones. That's great. You can also go to the Curio website, okay, for the mindset ones. The code is PS12 for today, okay, for Curio, PS12. All the multiple choice questions are there. There are 5 multiple choice. I'm just going to quickly go through them with you, but I'm not going to answer them for you, okay? So we want you to go through the questions as we go along. I promise I will do all the answers at the end of the show, okay? So you've got about just over an hour and a quarter to go through those, okay? And then we'll go through them together. So let's just go through what the multiple choice are. Which one of the following cannot be an alkene? Okay, so you've got to choose which of these doesn't fit into the alkene group. Okay, number 2. No, wrong way. Number 2, wrong way. See, I told you this board doesn't like me. Which one of the following is an unsaturated hydrocarbon? This one's a little bit of a trick question, so be careful. Don't just look at the double bonds. It's very important what they said there. That's unsaturated. Okay, so you've got to look at them. Number 3 said consider the 2 organic compounds. So we look and we go, well, we've got a ketone and an aldehyde. Hopefully you recognize those. And then they say which one is best represented by the list. Okay, so whatever's in the first column is the first compound. Whatever's in the second column is the second compound. I've pretty much given you the answer to that one. Question 2.4, what is the product formed when ethanol and propanoic acid are mixed together? They gently heated in the presence of a few drops of sulfuric acid. So this is quite a nice one. This is one of those where you're guaranteed to get asked questions about esters. So this is an ester question. And then the last one, and this one's actually a really nice question. I was looking at it earlier this morning, and I was like, ooh, this one could give you a little bit of a nightmare. But my suggestion, grade 12s, is that you actually draw them out. Okay, draw them out. That's going to be the easiest way to see it, because otherwise you're probably going to go for the wrong answer because you're going to get a little confused with the double bonds and stuff. So draw it out. That's my hint for question 5. It's a really, really nice question. Okay, so what that means is we've got a few more minutes left, and we're going to start the next question anyway. Now, with a question like question 3, my suggestion is, first thing you do before you even look at the questions, don't even look at what they ask you for, is let's just go through and, oops, that's not what I wanted, and let's name or decide what these compounds are, okay? Because a question, whenever you see a list like this, is they're going to ask you to identify compounds, they're going to ask you definitions about it, they're going to ask you to name them, they're going to ask you to draw isomers for them, they're going to ask you a whole bunch of stuff. So first thing we need to do is let's actually decide what we've got. So if we look at A, what type of compound is A?
An alkane.
It's an alkane, good. All right, so we know it's an alkane. And if we had to name it, it's 1, 2, 3, 4, 5, 6 in the longest chain.
Hex.
Yep, so it's hexane. Okay, and then we've got a methyl and another methyl, so it's going to be
2 and 4, and then hyphen dimethyl hexane.
Excellent. So it's 2 and 4 dimethyl hexane, and you know that it all becomes one word, hey?
Yeah.
And let's pretend we can read my shmush. All right. Well done on the 2 and the 4, because you went from right to left, hey? Good.
Thank you.
All right. What's B?
B as should I give you the answer or
What type of compound is it?
cyclo?
Yeah, it's a cyclohaloalkane.
Haloalkane, yeah.
So, but this is actually quite a nasty one, because it's got a double bond in it,
Bond, yeah.
and it's got a fluorine. So that's just mean, because they can be, and it's got a methyl group in it. So we know it's going to be cyclo something, and it's got how many carbons? 1, 2, 3, 4, 5. So it's cyclo.
Pent
what?
Pentene.
Pentene, good. Now, remember, with the numbering in your rings, is your double bond has to be at number 1.
Oh.
Okay, you've got to start with the double bond. Double bonds are more important than anything else. So we've got to make a decision, okay, as to whether we're going to go clockwise or we're going to go anti-clockwise. Okay, did you start at the chlorine or the methyl?
I started with
the fluorine, sorry.
Fluorine, yeah.
In a normal compound, that would be fine, but your double bonds are more important. Okay, so now we've got to, so we go, all right, if we go 1, 2, 3, 4, 5, then fluorine and chlorine and methyl go on 1, 4, and 5. That sounds a bit high. So let's do this. Okay. Ooh, wrong one. Ooh, there we go. And go 1, 2, 3. That's a bit better, hey?
No.
Yeah.
So what if I start, I make them 4 and 5 like before, and then?
Then it's wrong, because then I've got 2 big numbers, whereas if I go 3 and 4, they're smaller.
Oh.
So even though you would want the fluorine to be on 4 normally, because it's more important than the methyl,
yes,
you would only make it on 4 and 5 if it didn't matter which way around you went, you got the same numbers. Okay, good question though. It's a very good question. So what this would actually end up being, first of all, we've got to make sure that we know that this is on 1, okay? So it's 1 cyclopentene. And if there were no branch change, you can just call it cyclopentene. Because there's only one, it can only be between 1 and 2, okay? So this would be, ooh, sorry. See, this board doesn't like me, I'm just saying. Just so you know. Ah! It's just nervous.
Aye.
Yeah, no, it's just you.
Oh, me?
The board's nervous. It's not me. It's never me. I'm a teacher. I'm always right.
Yeah, you are.
I hope my kids are watching. Did you hear that? They don't believe me. Anyway,
No,
right.
it's
just pretend it's all in one word. Okay. 4-fluoro, 3-methyl, 1-cyclopentene. Okay. And we're just going to quickly name the rest. This one's nice because it's a triple bond, so it's an ion. Okay. 1, 2, 3, 4. So it'd be
1, 2, 3, 4. It's methyl.
4 is meth,
four.
F,
Beach.
bute.
Yeah.
Okay. And it's going to be on number 2. And
Yes.
this would then be on number
Number 3.
3. Yeah. So this would be 3-methyl and 2-butine. If you put the number in the middle, that's also fine, hey?
Yeah.
You know that, yeah.
Yeah.
And then hexanoic acid, this is an alcohol, carboxylic acid. I was about to write alcohol, and then I saw I was wrong. Okay? So it's a carboxylic acid. I'm not going to draw it out because we might need to draw it later, but I don't think that's where we're going to be going. All right, so we've now looked at the compounds. We have an idea of what they are. We're going to take a short break, grade 12s, and then maybe you guys, while we're taking that break, can quickly see if you can answer the questions that followed this. Okay, and then we'll do the answers when we get back.
All right, guys, I'm sure that you have learned so far. And for those of you that, for your friends who are not watching, please make sure that you ask them to come and watch the show. Tracy is really helping us in studio. I can see some of you guys are watching the show. Let me just name a few of you guys that are watching. Comedian Muremi, Gift Dibakwana, Sbusiso Btelezi, Sanele Shangwe, and Disiwe Maudu. Shout out to you guys and all of you guys at home for tuning in. Remember, we are with you right up until the end of this hour. Right now, let's take a break. We'll be back. Welcome back, guys. From that short break, we are giving away this nice CD coming from Soul Candy. Guys, please enter the competition right there on www.mindset.co.za/learn/stop the clock. That is the name of the competition. Go there and fill in that form so that you can win this nice CD. Thanking Soul Candy. Now, guys, I can see that you are bringing in interesting questions. Tracy,
yes.
This one is for you.
Okay.
And question 3, isn't C a pentene since it has 5 carbons in a long chain?
Oh, well done. Who was that?
That
was brilliant. Well done.
Okay, I'll get the name for
We'll
you.
get the name.
Yeah, I will.
You are 100% correct, whoever brought that in. Actually, as we went to the break, I was like, oops, we've made a mistake. And Sophie was about to correct me. You are correct. This should actually be pentine.
Pentine.
Yeah. Okay. Now, guys, well done. See, we've even changed the pen. Look at that. You said, no, like to me. Okay. We'll blame the pen. Guys, well done. I'm so glad you're paying attention. Okay, we all have those moments, and I'm no exception to them, which is why you always need to go back and recheck your work. You've got more than enough time. Okay, and into the competition, I'm showing my age in that I have no idea who that CD is by, but apparently it's quite a good thing. So I'm just saying, showing my age, moving on. Okay, but that's all right. Anyway, moving on. So, first question, and in fact, I think we actually answered most of the questions we got on, because first one said, which series does compound A belong to?
Alkene.
Alkenes. Okay, so we did that one.
Isn't it supposed to be an alkane?
Alkane? Yes, it is an alkane.
Let's blame it on the pen.
And I like that.
It is
She's
the
learning
pen.
quickly. We'll blame it on the pen.
It's the pen. It's not Tracy, guys.
It's the pen.
pen.
It's the pen. Yeah. He's gonna come back. I think every live show from now on. Okay. Anyway. All right. You and the name for compound A, which we did earlier.
For compound A, it's 2, and then 2 and 4.
Yeah.
Hyphen dimethylhexane.
Yeah. There we go. And now you can actually vaguely read that. 2,4-dimethylhexane. We were fine with that one. We did name B. What did we call it?
We named it 4-fluoro 3-methylhexane. Is it fine if I just say 4-fluoro 3?
4-fluoro, yeah, absolutely. So it was
leave the hyphens
4-fluoride.
out. 3-methylhexane.
Methyl.
Oh no, sorry,
cyclo.
cyclo. Sorry.
Okay. And here, even if you don't put the 1 in, it's okay because there's only one double bond in it. So if you put the 1 in, great. If you don't, it's not a train smash. I'm going to run out of space, so I'm going to put it here. Or cyclo. Pentene.
Pentene, yeah.
Okay, let's go further down. Cyclopentene. Okay, and then we've just had compound C corrected because we did get it wrong. It was 3-methyl-2-pentine, okay?
Yes.
Now, the thing here is we spent quite a bit of time before the break. I still need to actually pick up my pen. You said 2-pentine, hey?
Yes.
Pentene.
Pentene.
Pentene or pentane? It was iron.
Y-N-E.
Yeah. All right. Now, we spent some time before the break actually looking at the compounds in the box and talking about them and stuff. And then we got to the questions, guys. It took us, what, 30 seconds to do those questions?
True.
So use that time. I know what you try to do is you look at it and you go, okay, let's start answering the questions. Read through the information you're given. Make sure you understand the information and then look at the questions because that's the easiest way to get through these, okay? And now, okay, they gave us question 3, so we're actually moving along quite nicely. Let's look at question 4. It says to you, in the petroleum industry, smaller, more useful hydrocarbons are obtained from larger ones by a process called cracking. Okay, this is really important. So even though we mine natural gas, we mine oil, we mine crude oil, all those things, we take the crude oil, goes through that whole fractional distillation. Do you remember doing that last year?
On grade
Well, you
11.
did in the tower. That's what I was looking for. During the time, then you get all the different hydrocarbons and the fractions and stuff that come off. Okay. You don't need to know all the detail about that anymore, but you do need to understand the process of cracking. Okay. So the first thing they ask us is to define the term hydrocarbon. So how would you define a hydrocarbon, Fiso?
A chain of carbon molecules bonded to hydrogens.
Almost. This is a pure definition, though. So this is one of the things. My suggestion for definitions is, this is what I tell my learners to do, is as you go through, you know, because by now you should be doing study notes and stuff, get one of those little spiral notebooks and you make almost like a dictionary. And you write the definitions down. It's the last thing you learn is your definitions, okay? And the term hydrocarbon, it's an organic compound that consists only of carbons and hydrogens. Okay. But I just realized we actually missed out a question in question 3.
Yeah.
And I've got a feeling we have very jacked Facebookers today. So should we go back and do it quickly?
Yeah, let's.
Let's do that quickly. Before.
I did it actually, and.
Now you see. And then you were like, nah. Okay. So, formula for compound D. Compound D was hexanoic acid, right? So, hexanoic means how many carbons in the longest chain?
It's 6.
6. Good. So we've got 1, 2, 3, 4, 5, 6. An acid always has what in it?
An acid.
Yeah. What's the functional group for an acid?
Is it OH?
The OH that is the alcohol part, and then it has one other thing.
The double bond and the carbon.
The oxygen. Yeah. Okay. And it's always at the end. All right. So for an acid, it can be nowhere else but at the end. They terminal. All right. But now this is not the diagram. You will not get marks for this, grade 12s. You have to put in, and as much as it irritates all of us, is you put in all the hydrogens. And now I know I have some learners who have very, very, very small handwriting. Okay, their handwriting is like, I need a microscope. Please do this a bit bigger. Make sure that we can see all of it. Make sure we can actually see the double bond. Also remember, you must show the bond between the oxygen and the hydrogen. Before, and if you look at the older textbooks, we never had to show the bond between the oxygen and the hydrogen. You now need to show that, okay? So any covalent bond, any place where we have a sharing of electrons, we have to show that bond, okay? All right, so let's go back to question 4.
Question 4.
All right, wrong way. There we go. So we've defined it. Now, compound C10H22, we don't need to know its name. You don't have to name above 8 carbons in the longest chain. It's cracked, so we break it up to obtain X. and another hydrocarbon. The cracking reaction is represented by the following incomplete reaction. Okay, so now we look at this and we go, all right, we started with C10H22, we've got a C5H10, and now they want to know what X is. So how many carbons are left over if we started with 10 and we now I have 5?
We're going to have 5 carbons.
Good. And how many hydrogens?
11.
Almost. We had 22. There's 10.
12.
12.
Yeah.
It's okay. Remember, to find X, whatever's not used in the one we had over here has to be used in X.
Yes.
Okay. Otherwise, it's not a balanced equation, and there's nothing else left over. Okay. So cracking is we divide the two. So we get C5H12. Then they say the cracking process requires high temperature because it's remember, you're not breaking an intermolecular force, you're not breaking van der Waals, it's not like boiling or evaporating, you're breaking an actual sharing of electrons, lots of energy required. But we often have to use a catalyst. Why would we use catalysts? What do they do?
To heat, and
it helps with the heating, but it's to speed up the reaction. So we would use a catalyst to speed up the reaction, okay? And they want 2 reasons. So we've got to think about and go, well, the first of it is it speeds up the reaction, but what does it do? What is it? This is a little bit of rates of reaction now. Because remember, a catalyst has more than one. The function of putting it in is it speeds up the reaction, but it speeds up the reaction by lowering the activation energy.
Yes.
So that also means that we can do this at a lower temperature, which makes it safer. Which is what we want. Remember, we're doing this at very high temperatures, good couple of 1,000 degrees Celsius. This is dangerous, okay? And it's expensive. It's very expensive. If you remember when you did equilibrium, you should have done industrial processes a little bit.
Yes.
And you talk about contact process and all of those sort of things. So you sort of go, well, why do you need to use certain temperatures and pressures? Because it makes it go faster and it's more economical. So it's that whole time issue, money issue, but for catalyst, it makes it go faster and it means that we can use a lower temperature, which makes it safer. Okay.
Okay.
Then 2-methyl-but-1-ene is one of the compounds formed, and the first thing they ask you to do is to draw the structural formulae. Well, that's not so bad. Can you see I've already, so far, in the questions we've done naming. We've already drawn once, and now we're drawing again.
You're drawing again.
So the naming and the drawing is very important. If that's the,
very important.
Okay, I'm not going to say it's the only thing you should know how to do, but it's a big part. Even if you're not sure about the rest of the organic chemistry, make sure you can name and draw. Okay, you'll get some marks. So we always start at the back. So it's but. But means?
But means 4.
4. Okay, so we're going to go 1, 2, 3, 4, and it's but-1-ene, so the double bond sits
and the first carbon
between
yeah,
1 and 2.
1 and 2, yeah.
And then on the second one is the methyl group. Now, whether you draw it up or down, it doesn't matter. Grade 12s, it really is a preference. I would say look at the rest of your writing on your page, and if you draw it up, if it's going to go smush into other writing, draw it to the bottom. It doesn't matter. Okay, so there's my methyl group, which then I put in all the hydrogens, which should actually look like a hydrogen. Let's just make it look like a hydrogen. Okay, now, this is where you've got to be really careful, because now we know we've got to add in all the other hydrogens to make this complete. So the one on the right over here, that's fine, that's easy, that's 3 hydrogens. This one over here needs 2. And now we've got to be careful, because now what happens is you get all excited, you know that there's got to be hydrogens around all of it, and you put another hydrogen on the second one. That would be wrong, because this carbon already has, if we look at it, I'm going to do it here, 1, 2, 3, 4 bonds. It can't have any more. Okay? So if you go and put another hydrogen over here, you lose your marks. It's wrong, because now you're saying the carbon makes 5 bonds, but you know it can't. Okay? So be careful. The carbon at the end already has 2. It's a double bond, which means I can only put in 2 hydrogens. They're not overly concerned about the shape, though you should know that it goes off at an angle, okay? If you draw it in like this. So if you would prefer to draw it in at right angles and you go hydrogen and hydrogen, they will accept it, but do not draw it up and down. Okay, and the only reason why we're so fussy is, remember last year you spent a lot of time doing vespa and shapes of molecules, and
Yes.
this comes from that. Okay, from the number of electrons and the way it will space itself out, and they're sort of expecting you to remember a little bit of that, though they're not going to ask you directly. Okay, then name. So this is actually very similar to what we did in the one-word answers. Name the type of reaction that occurs when 2-methyl-butanene reacts with hydrogen. There's a double bond. Okay.
Okay.
So what type of reaction will we get if we add in something to it?
Addition.
Addition. Okay. It's addition. If you called it hydrogenation, there's the I think they would give it to you. I'm not sure, because they're not. Remember in the one-word answers we said what type of addition reaction was it. Here they want just the general reaction. Okay. So remember, addition is because I can break the double bond, add. Substitution is when there's only single bonds. So alkenes and alkynes can have addition reactions. Alkanes have substitution reactions. But the substitution can be hydrogenation, or it could be halogenation, and so can the additional. Okay. All right. So that gives us to question 5, but are there any? I just don't want to start question 5 and then we're going to have to go for a break in the middle of it. Sophie, so are you okay with what you've done so far?
All right, thank you.
You're good.
Yeah.
Okay, so far it's just the mindsetters sending shout outs. So I'd like to say a shout out to Emmanuel and Khotato. They're also watching. No questions so far though.
Oh, that can't be. I'm brilliant.
Yeah, hey.
Okay. Let's just go back here. Let's just go back to. Okay. Okay. No, I think it's time for a break. I think we've done what we needed to with the cracking. They won't go into any more detail with cracking, guys. Just because it's not, it is important. What they might ask you in terms of the cracking to add to this is to ask you things like, why do we crack? In fact, one of the questions, why do we crack the hydrocarbons? Why don't we use them as such big compounds? Remember, the bigger they are, the stronger the intermolecular forces become. The van der Waals forces increases, the harder it is to burn them. And that's the whole point. With all of the cracking, we're trying to get fuels, which of course we know if you'd want to watch After Earth and all the rest of it, that's a problem. Okay, we actually need to stop our reliance on our fossil fuels, because when we burn them, we get all our greenhouse gases and carbon dioxide and all the rest of it. But we crack them to make them smaller, to make them burn more efficiently. Okay. So I think that's a good place to take a break, and we'll see them afterwards.
Yes, so we are going to be seeing you guys right after this break. Remember, there is this place where you directed the mindsetters at home to go to in order to do the Curio.
There we go. Yeah.
Yes, guys, please go there and do that multiple choice questions, and then at the end of the show, towards the end of the show, we are going to be going to them again.
Yes, we are. I'll go through all the answers.
All right, cool, guys. Let's take a break. We'll see you after this. Welcome back, guys, from that short ad break. You are still watching live the winter school exam revision. Guys, we are still giving away that nice CD right over here by Cuba. Thanking Soul Candy for giving us this opportunity to be giving our mindsetters these nice CDs. Now, guys, this is very simple. The only way you can get to enter in order for you to stand a chance of winning the CDs that we have is to go straight to mindset.co.za/learn/stop the clock. That is the name of the competition. And right now, I'm going to quickly ask Tracy to please check for us the last number of our likes.
She's trying to. She's not doing very well.
Okay.
She
okay,
lost
cool.
it. We were doing well. We were like.
We were doing well.
Yes, we were. I'll find. Do I have to do it there? I don't know. I lost it.
I think you're somewhere there. Yeah, I think you're somewhere there. Let's see. All right, cool.
Anyway, we were like 45,311.
Yes.
I think something like that.
All right, cool.
And now The
And
thing
now-
though is, remember, the whole thing with Stop the Clock
Yeah.
is to try and guess the number. So the number at the end.
Mm-hmm.
So if it was 4,300, I'm sure it's somewhere. I'm
Yeah.
going to get shot.
Okay, guys,
I'm just
no
saying.
worries.
No, it's fine. But
Yeah.
if say it was 4,000, I think it was 45,311 the last
yeah.
time we looked. Okay. And your number you guessed was 0. You need to get it to 4,320.
Yeah.
You need to get 9 of your friends to like the page.
Yeah, please, guys,
Yeah.
do get them to like the page. You can choose any number that you want from 0 to 9, any number, any one of them. All right, cool. Remember, don't post it on the wall, because if you post it on the wall, then it's not really going to be considered, so you don't want that, because you want that Cuba CD, right? All right, cool, guys. Let's just get straight to more learning, and please
Yeah.
bring in all of your questions. We would really love to ask Tracy to answer them for you, because we are live and want to help you. Let's work. Let's do this, Tracy.
Let's do this. You know what? I'm showing my age. I can't find things on the page.
Yeah.
And I have Facebook.
No, it's the board, Tracy. Hey?
It's the board.
It's not you.
Board.
The board. Okay, so guys, you are doing really great. I know I'm going a little fast, so I'm going to slow down a bit. I'm sorry. I just get really excited about my subject. Anyway, now, this question 5, this is a really, really, really important question. You are going to get a question with trends, okay? Now, with the trends, grade 12s, we're talking about things like boiling point, melting point, vapor pressure, viscosity, those are about the 5 that they're going to use, okay? All of them follow the same trend. So what we're really looking at when we do these trend questions is we're looking at the intermolecular forces. So you need to understand what affects the intermolecular forces, like the type of functional group. So whether it's a polar functional group like the alcohols, okay, or it's a non-polar molecule, which your esters tend to be because they have the non-polar on both sides, okay? Or whether it's about the length of the chain, how long they are, what the molecular mass is, as well as the shape. This one in particular is looking at the number of branches, so it's looking at surface area. The more of these questions you do, grade 12s, the better you are at recognizing the trends, okay? So do yourselves a favor, make sure you get the past papers. They're very, very important. This is new to the curriculum and it's not going anywhere, okay? So we have 3 compounds here. And the first thing we need to look at is okay, fine. We're looking at the trend in boiling points. And if we look at the compounds, let's just analyze what we've got, okay? So we've got, 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5. 1, 2, 3. So the same number of carbons, okay? So it's not the carbon chain length that's the problem. And it's all single bonds, so they're all the same alkane, okay? They all fit into they have the same molecular formula, which means these are all what?
They're all alkanes.
They are, with the same molecular formula, different structure,
Structural
which makes them
isomers.
isomers. Okay. So we're looking at, that does say isomer. Let's just do it. They're all isomers, okay? Same molecular formula, they C5, okay? So they C5 and it's H10. But we're changing the amount of branches, okay? So in number B we have 1 branch, and in C we have 2 branches. As the number of branches increases, the boiling point's getting lower, okay? Because what's happening is you're going from a long straight chain, you're making the chain smaller and you're giving it more curve. That makes the surface area smaller, okay? So you're going from, this would be a large surface area, and this becomes a small surface area, okay? And in fact, this one becomes more like a sphere. And a good way to remember this is, remember raindrops, water, if there was no gravity, water would always, the drops of water would be perfect spheres. But gravity makes them give that teardrop shape. A sphere, a ball, has a smaller surface area than a long chain, okay? The longer the chain, the more the particles can, the more surface area there is for the intermolecular forces to act over. So they have a stronger intermolecular force. The stronger the intermolecular force, the higher the boiling point, the harder it is to break them apart. When they become balls like that, remember, it's like trying to put a whole bunch of balls together. Smaller surface area interaction, smaller intermolecular force. You can't talk about mass. Be careful with this one, grade 12s, all right? Sometimes, if we had, say this was C5H10, then C6H12, and then C7H14, no, it would have been, anyway, you get it. The mass would be an issue, okay? Mass becomes an issue with intermolecular forces. Newton's law of universal gravitation still applies, okay? Still applies, in that the bigger the mass, the greater the intermolecular forces. But same mass. So that doesn't matter here. Now it is to do with the surface area, okay? I haven't even looked at the question yet. In my head, these are the sort of things you should be thinking about, okay? Is you go, okay, we recognize that they have the same formula, C5H10, which means that their mass is all the same. Okay, so that's a control. If this was an experiment, because I could go that way, I could ask for a control variable. I could turn this into an experimental question. I could ask you what the hypothesis was. So you would look at, the hypothesis would be, if it was the same mass, it would be, if I increase the mass, the boiling point would increase, something like that, okay? I could ask you here for an hypothesis, if I was being really horrible, and there we would say, well, if the surface area decreases, the boiling point decreases. Okay? We could, and remember with a hypothesis or an aim or anything like that, you've got to state a relationship, guys. This is really, really important. And by relationship, you can't just go, a relationship means that if one changes, how does the other change? Plus, so you've got to have three things in a hypothesis. You're going to have the variables you're checking. So if this was here, I'm checking boiling point and surface area. I'd have to have both of those included. I'd have to have the relationship between them. If I decrease surface area, I decrease boiling point, something like that, okay? And I'd have to have the control variable. This is the thing that normally gets left out, is the control. What stays the same? And in this case, I'm keeping the same mass, or I'm keeping the same group, so they're all alkanes, but the same mass is actually the important part here. If this had been to do with the change in mass or length of chain, then I would say if we increase the number of carbons in a chain, the boiling point will increase, provided it's the same homogeneous series. Okay, provided we keep it, whatever we keep in the same. That's really important. That's how, it's also, remember when you learn things like Boyle's law from last year, okay, you won't get asked this year, in a fixed mass of gas, control variable, one of them, the pressure and the volume are inversely proportional relationship, provide temperature remains constant, okay? Be careful here with this, and I'm going completely off topic for the question, but I just want you to get this. If I ask for a hypothesis, I would be hesitant to use the words directly or inversely proportional. If we say it's directly proportional, that means that if I double one thing, the other thing must double. Here, I can't work that out. So unless I could actually work out that the surface area decreased by a certain proportion, then I could work out that the boiling point decreased by the same. Okay, be careful with using those. They'd probably give it to you, but I'm a little hesitant to use them in this situation because it's not as simple as that. It's also, particularly with mass, is to say mass is directly proportional to boiling point. I'm a little hesitant because just because we doubled the mass of a compound does not mean we're going to double the boiling point. In fact, we wouldn't double, probably more than double, because it depends on how it all now interacts with each other and how because if we double the mass of this, it becomes a longer chain. Longer chains actually start to all bend in on themselves, and as much as we draw these as straight compounds, they're not actually Small ones are, but the longer they are, the less straight they become. You guys okay with that?
Yeah.
I've
good.
just completely jumped off topic, but that's okay. That's one thing we don't have
It's
here is
helping.
any experimental type questions. And you're going to get grade 12s. I promise you, you are going to get a question where you're asked to find control variables, independent, dependent, hypothesis, or aim. You'll get one of those two. Please make sure you understand what we mean by those. Okay, so we have those. They're all C5H10. First thing they ask, and we answered this long time ago, is why are the above compounds considered to be structural isomers? Sfiso?
Because of the same mass, and
Almost. What would be a better way to put it? Because it has the same,
same number of carbons and hydrogen.
but different.
Different structural formulas.
Different structure. So the same molecular formula.
Okay.
Same molecular formula, different structural formulae. Okay? Same molecular formulae, different structural formulae. Okay? That's for 5.1. Now, very important word here. This question is actually quite important because it's worth 4 marks. Look at the mark allocation. My learners wrote their June exams, and some of them are going to be very upset when they get them back next term because they had a 4-mark question, and some of them wrote an entire page and got 0 because they didn't look at what I asked them. Okay, so be careful. Or they wrote an entire page and only got 1 mark because they're just not answering the question. It says to you, first thing, describe the trend of the boiling point from A to C. First, that would be worth 1 mark. So if we look at A to C, what happens to the boiling point?
It increases
From A to C,
from A to C,
it decreases,
decreases.
gets smaller.
Oh. Okay.
It's okay?
Yeah.
Right? If you wrote increases, then you would have to write from C to A. Okay?
Yeah.
They would accept both in the answer, but I would tend to want to answer the question the way it was asked. Okay?
Okay.
So they said from A to C.
From A
So-
to C.
From A to C, boiling point, and you would write it out, decreases.
Decreases.
Decreases. I'm just making sure we're all awake. Okay. So that's the first part. Now, that would get you 1 mark, maybe 2. Explain the trend by referring to, number 1, molecular structure. That would get you 1 mark. Intermolecular forces, 2 marks. Energy involved, that's your 3rd mark. Okay? So the way you describe this is really important. First of all, from A to C, now we spoke about this. From A to C, the surface area became smaller. So what we would write is we would say from A to C. So, and you know what? Write it in point form. Write it as bullet points. Write each new fact on a new line. What you need to remember is your markers sit in a room for 12 hours. We get tired. Make it easy for them. Write neatly, write clearly, and write to the point. Okay, so from A to C, the surface area decreases. Okay, I'm going to run out of space. I'm just going to do a downward arrow as molecule becomes more structured. It becomes more branched. Okay? So that's the first thing. We've already looked at the molecular structure. It becomes more branched, surface area decreases. That means the intermolecular forces, which I'm just going to call IM, also decrease. Okay, now I've done it in point form. This is a little too point form-ish. Okay, make sure you write it out in full for your examiners, okay? Therefore, less energy required to break the bonds.
Yes.
To break your intermolecular forces. Your 4 marks are there. Okay. And I've referred to everything that the question told me to refer to. This is the issue. Is they're telling you exactly what they want in your answer. So they're not just saying explain the trends. they're saying to explain it in a very specific way. So they want you to see, okay, the intermolecular, first of all, decreased as it went down. Why? Because the structure went from a long chain to a smaller chain, okay, became more branched, surface area decreased, that decreases the intermolecular forces, which then decreases the amount of energy required to break the bonds. You could have described it the other way around, grade 12s, okay, which I know some of you will do, is you could have said, well, from C to A, the boiling point increases. Why? Because it goes from a round chain to a long, and that's fine. But make sure that your first line says exactly what you're describing, okay? Because if you want to do from C to A, you have to say that you're doing C to A. The question asked for you to describe the trend from A to C. So if you answered the question exactly as given and you didn't write in this part, and you said the boiling point decreases, fine. You've answered the question. However, if you don't write from C to A, and then you write the boiling point increases, I can't give you the marks. Because the question said
from A to C.
So we assume however you've answered it is the way the question was asked. Okay, so just be careful with that one, grade 12s. You can do it either way around. Just be careful.
Okay, so Tracy.
Yes.
Going to Kaylin.
Yes.
Mugaba wants to know, ain't we supposed to start counting from the longest chain if there is no double bond in between the carbon atoms?
Okay, I think they're referring to a naming problem.
Yeah, I think so.
Yeah,
Okay.
with this one, okay, there are no double bonds, but they are actually all there's the same number of carbons in
Okay.
each of these guys. I know if we had to name them, they'd all have different names, but if I simply counted the number of carbons, irrespective of the bonds, each of these have got 5 carbons and 10 hydrogens. If you have to go and count them, they are isomers, their names will all be different, and maybe after the break we'll name them quickly, because we have run out of time, we have to go to a break, we'll name them afterwards, but they all actually have the same number of carbons and hydrogens. Okay, I think that helps for me. I tell you what, let's take a break, and maybe you can ask our Facebooker to just sort of tell me where she got the question from. But afterwards, I'll name these compounds for them. I think it'll make it easier. Yeah.
Okay, cool.
Okay.
All right then, guys. Thank you for keeping those questions coming onto our Facebook page. It is mindset.co.za/learn/extra/winter school. This is what we are doing this week, guys. Winter school revision, exam revision. All right then, guys, let's take a break, and when we come back, I will be explaining a little bit more about the competition that we are having. Hello Mindsetters, and welcome back from that short break. Now guys, before the break I told you that we are going to be explaining just a little bit more about this competition that we are having, and thanking Soul Candy for giving us these nice CDs that we have to give to you guys. Now this is Cuba, and any one of you guys will be walking away with this nice Cuba CD right over here. So what basically happens is you have to choose any number between 0 and 9, and Tracy right now will be showing us the last digit. Any lucky number from the number of
Let's
lights.
see what we've got.
Okay.
The last digit is 8.
8.
So
Ooh, guys, all of the guys at home, the Mindsetters who chose number 8 are standing a great chance of winning this Cuba CD. Now guys, at the end of today's live shows, we will be giving away this nice CD bag. Let me show you fast. Okay, cool. There you go. This is the nice case that we are going to be giving to any Mindsetter at home at the end of today's live shows. So please do stay tuned with us so that we can announce who the winner is. And that number 8 we are going to be announcing just a little bit later on. Right now, we're still learning with Tracy.
Okay, I think I should be where they are and watching the teacher. He maybe knows what she's doing, because I'm not having such a good day. And I want the CD case.
Oh, yeah.
Anyway,
but we
moving
can't
on.
have it
So,
for the
okay,
Mindsetters.
we've figured out what the question was earlier.
Mhm.
And the Facebooker, sorry, I can't remember your name. I'm terrible with names.
It's a Kiabetsui.
Yeah, I'm not going to try butcher your
Kia.
name. I'm sorry, sweetie. Okay, you
Yeah.
are 100% correct. We have found
Yeah.
another mistake. Oh, my
Yeah.
word. So I'll tell you what we're going to do is let's just take this off altogether and let's rename this from the start, okay? Because we have 1, 2, 3, 4, 5. So we know it's going to be pentine, so we're good with that. And it's going to be 1, 2. So that goes into the 2. So we know it's 2 pentine. And we've got 1, 2, 3, 4. And the methyl group goes on 4. So it's 4 methyl pent-2-ine or 4 methyl 2-pentine. Okay, so you are correct. I'm sorry, I apparently am having a serious counting problem today. I do apologize, grade 12s. And here's me telling you how important it is that you can name them, and look at me. Anyway, so back to question 5, which we were doing really well on. And let's just name these compounds anyway, just because I think I need the practice. So we have 1, 2, 3, 4, 5. So that makes pentane.
Pentane, yeah.
Good. Okay. And this one is 1, 2, 3, 4. So it makes it butane. And where's the methyl group?
On the 3rd carbon.
Is it on the 3rd carbon?
Yeah. No, 2nd.
Good.
Yeah.
A little bit of a trick question, okay? Because look, if I number from right to left, so I go 1, so it's 1, 2, 3, 4. It is on 3, but it needs to be on the smallest one. So we need to go 1, 2. All right, so I'm going to run out of space there. So let's just write it over here. So it's actually 2 methyl butane. And then we've got 1, 2, 3. So it's propane.
Propane, yeah.
Okay. And we have 2 methyl groups, okay? This one, we would call it dimethyl propane. Okay. Where are the methyl groups though? What number?
What number? This 2, number
2.
2. Yeah.
Okay. You don't have to put the numbers in on this one because if they're anywhere else, then the longest chain changes place. Okay.
Yeah.
So if it was on 3, then it actually becomes a version of butane. So that actually doesn't help us at all. So you can put the numbers in, but in this case, if you don't, it's fine. You won't lose any marks because it can only be on the second one. However, if you put the numbers in, you're not going to lose any marks anyway. So I would rather say put the numbers in to be on the safe side.
Yeah.
Then don't put them in just in case. Okay? And then the last question here, which we actually did answer a little bit earlier today, was give a reason why branched hydrocarbons are preferred to straight chain hydrocarbons as fuel. Think about their boiling points. Their boiling point's much lower, so what would happen? Would they burn better?
I think they'd burn better.
Absolutely. Remember, when we're talking about fuels, think about in your car. If the train is too long or the intermolecular forces are too long, it requires far too much energy to get it to burn the fuel, which then means it takes too much energy to get energy out in the first place, so it's inefficient, okay? Or if you burn in paraffin at home or you have a gas heater or something like that, you don't want to have to put a lot of energy in to get something out because that sort of defeats the object, okay? So the smaller the branch, the better it burns, okay? So it becomes more efficient, which is what we want. The less energy we need to start it burning, the better. Okay, we get a much bigger amount of energy out at the end. Okay, so question 6. Now, Safisa said earlier this is the type of question he hates. I love these questions personally. Okay, this more so than any of the other questions, before you even look at the question, make sure you understand the flow diagram, okay? So they say to us, we have X, Y, and Z, okay? They represent different organic reactions, which eventually get us to the same place. We starting off over here, and we've got a haloalkane,
Yes.
okay? And in this case, it's 1, 2, 3. This would be a butane. Okay,
Yeah.
I put it there. So, and we've got a bromine on it. So this would be 2 bromo 2-methyl butane. Okay, so we've got a haloalkane. We're then taking the haloalkane and we're making it into a double bond. Okay, now as soon as we go from a single bond to a double bond, it is an elimination reaction. Okay? It's an elimination. Because what we're actually doing, and if you look at this very carefully, is we've taken off the bromine. The bromine's gone here. So somewhere along the way, we now have bromine over here.
Yes.
Okay, which probably be Br2. We'll talk, it would have to be Br2, but we're not going to worry too much about that, okay? We've taken it away. Then we went from this one to here, but we've taken this, we'll go back to that one in a second. For Y, we've added potassium hydroxide, and it's an OH. This would be a substitution reaction here. Y would be a substitution reaction. The bromine's going to come off, and the OH is going to go onto it. So I'm going to make an alcohol. Okay, substitution reaction. However, from Z to here, I've got a double bond, which I'm going to have to break, which means this would be an addition reaction. Okay.
Yep.
So guys, the first thing we're doing is we're looking at this and we're going, okay, let's just make sure we understand what the reaction's doing. We have an elimination reaction to X. We have an addition reaction for it to get to Z if we're going to take the double bond away, which means we must have a substitution reaction because of the OH. Okay? Generally, when we see an OH, we're probably going to make an alcohol. Okay?
Yeah.
It might change a little bit along the way, but we'll see how it goes. And we're not going to try and name P just yet. We're just going to have a look and see where we go. Okay? So 6.1 says name the type of reaction. You've already answered it.
Name the type of reaction by X. It's elimination.
Elimination.
Yeah.
Already did it. Didn't even have to look at the question. Okay? So we've named the type of elimination reaction. Then, state two conditions. Now this is straight learning. So if we look at X, okay, and we go fine, reaction X is the elimination reaction. We know it's an elimination reaction. So now we've got to go, okay, how do I get, now this is one of the things we just learn. Okay, so in an elimination we need two things. One, we need heat. Has to have heat because we're actually taking something away. And a good way to remember it is whenever I want to take a bond away, I've got to add lots and lots of energy to it. Okay, so heat's the first thing. So we know we're going to need heat. The second one is a little more difficult, but it's one of those things you remember. For any elimination reaction, we actually need a concentrated base. It needs to be a strong base, though. So you can use sodium hydroxide, potassium hydroxide, any concentrated strong base. Okay, any concentrated strong base. Generally, we will use sodium hydroxide or potassium hydroxide. In a lab, those are the ones we have most of the time. Okay, but any of the strong bases. Then they ask you, so heat, and we need a strong base. Okay. Next question. Now they say, apart from the organic, okay, no, I've missed out 6.3.
Yes.
Thank you, there we go. Reaction Y represents a substitution reaction, which we just said anyway. Remember, we did that in the, when we were looking at. Write down the structural formulae of compound P formed in this reaction. So now let's look at this. Okay. Substitution reaction means, we said we've got the KOH, the potassium's never going to get added to the compound. Okay? Never going to happen. At the level that we do organic chemistry, the substitution would be with whatever's not a carbon at this point. If there was no bromine here, then it would be one of the methyl groups that gets substituted. But because there is the bromine, it's the bromine that's going to get substituted, okay? Now, they want the full structural formulae, so this part is easy. It was 3 carbons, okay? So 1, 2, 3. We still have the methyl group that we had over there, okay, which I've gone into the writing, so you'd have a little bit more space, and this methyl group. But now instead of the bromine, we have OH. So we've created an alcohol. And we make sure we have all the hydrogens and stuff that we need around it, okay? Now it says, apart from the organic reactant, write down the name or formula of the other reactant needed in reaction Z. Now, Z here was the addition reaction we said. But we now need to go from this double bond being broken, and look where we're going to. We need it to look like this, with the OH. It can't be a base. So it can't be potassium hydroxide, any of those sort of things, because that's not going to help us. It's going to be water.
Water.
Okay. Now it's nice. They said formula all names, so it's fine. It's water, H2O. You can give me either. And how do I know that? Because I learn the conditions, okay? So you learn for the easiest way to learn these is to almost try to set up like a whole bunch of flow diagrams, particularly for people like Sophie who hate them, is if you can take an alkane, a basic alkane, and you can change it into an ester and go through all the ways to do it as a flow diagram, you can answer anything.
Okay.
But that takes a little bit of thinking it through and
Yes.
bringing it all together. That's what makes organic chemistry difficult for you guys, okay? Is there's lots of possibilities, and you're not going to have seen them all. There's no way we can do all of them with you, grade 12s, okay? We can only do a certain amount, but they all fall in the same pattern. So you've got to learn the patterns, okay? Now, name the type of reaction represented by Z. We did that.
It's addition.
Addition.
Yes.
Okay, there we go. It could also be hydration, hydrolysis, okay? But it's addition. You guys okay with that? I mean, we've got, sure. We've done a lot. We are going to take an ad break, and then I can get to the multiple choice questions, so I hope you've done them.
Yeah, hey. All right, then, guys, I can see that you are watching the show and asking questions. Right over here, I have Tandem Tombeni and Solia Rojic thinking that Tracy is really making the simple chapter easy. Thank you, Tracy.
You're welcome.
Yeah. Yeah, otherwise, we also have Eline saying, shout out to Mindset. I really now understand how to answer exam questions. Loving these classes. We really do appreciate you guys liking the show. Please share with your friends as well. Ask them to join us and ask the questions. Whatever it is, we are here to help them. It is the winter school exam revisions. Right now, let's take a break. We'll see you shortly after this. Welcome back, guys. I'm sure that you are now refreshed. You had a glass of water, and this is the last segment of this live show right now. We are going to be having other live shows to before the end of today. But right now, guys, let me just quickly announce that we do have the winner, but I will give you the name of the winner of this nice and cool CD. Now, guys, remember, if you keep on watching our live shows until the end of today, one of you could be walking away with this nice case, all right? It has nice little bags in it where you can keep your CDs inside. Now, guys, thanking everybody that is busy liking our page. You know, it's really awesome. I'm seeing all of you guys. There's Daisy, there's Sinovuyo, Kitumeti, Sola Rejek, Kitloto, Kaukelo. You guys really are amazing. We are really hoping to answer all of your questions. Let's interact, and please tell your friends to like us on Facebook. Right now, let's just carry on with more learning.
Excellent. I'm so glad you got to say those names. Anyway,
Yeah.
I just call my kids Sweetie Pie, Pumpkin, such things in my class. They all respond to these now. They all know, otherwise I just butcher their names. I'm sorry. Anyway, we're going to go through the multiple choice. We are going to do it backwards, guys, because we've looked at those of you that have actually done the Curio questions. Well done. We're so glad. It's actually a really good indication for us as to what you're struggling with. So we're going to go backwards because 2.5 is one of the ones that wasn't answered so well. The thing with 2.5 is I think sometimes we get a little confused, and the thing with 2.5 is you actually need to draw these out. Okay, it's the easiest way to do it. I know it takes your time, and but it's multiple choice. You've got to be able to do it quickly. not really. You have a 3-hour exam. Okay, you have plenty of time to write these out. So let's start with the 2-methyl-but-1-ene. Okay, so 2-methyl-but-1-ene. So that means but is 4 carbons in the longest chain. So 1, 2, 3, 4. It's but-1-ene. So that's on the first and the second one. And then we have our methyl group on number 2. Okay, so if we add in all the carbons, make sure you don't add in too many. Okay. The second carbon can't have any hydrogens in, otherwise it's got too many, and the first carbon can only have 2 hydrogens. So that means I've actually got C5, okay, 5 carbons, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 3, 6, no, 10. 1, 2, 3, 4, 5, 6, 7, 10. I can't count either today, apparently.
It's the board.
It's the board. He's learned so quickly. Okay, H10. That means when I look at the next 4 compounds, I must have 5 carbons, 10 hydrogens. Okay, so that's what I want. So let's take this one away. I'm not concerned about structure now, so let's look at the next one. 2,2-dimethyl-prop-1-ene. Now watch it. 1, 2, 3. Prop-1-ene says that. Now look at what they've done here. 2. There's a problem. Can that carbon have 5 bonds?
No.
No, this doesn't even exist. Doesn't even exist because that carbon's got too many bonds on it. So that's not an option. So we know it's not A. So let's get rid of that one. Next one was hexene. Hex means 6, so straight away I can actually see that it can't be hexene because there's 6 carbons. So, well, that's only 5. So already I've got 6 carbons. That's a problem because I can only have 5, so it can't be hexene. Okay, let's take those away. Pentane, now we're looking, okay, pentane's got 5 carbons. It's 5, so 1, 2, 3, 4, 5. Let's see how many hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can't be pentane either. Maybe it's cyclopentane. So we go, okay, let's have a look. Cyclopentane means I've still got 5 carbons, but they are now in a ring structure. Okay, so 1, 2, 3, 4, 5, and then a ring structure. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cyclopentane. Be very careful. Your cycloalkanes, ringed alkanes, are actually isomers of your alkenes. So be careful. Okay, draw them out. Make sure you do that. Sometimes, like the hexene was easy to see because it was C6.
Yes.
I mean, that was easy. But the other two, not so much, the A and the B. And in fact, I've got a feeling a lot of you probably said that it was A. Because it's it's an easy mistake to make.
Yeah.
But that's why you need to draw it. It's the pentene. The A would have been an option if it had been 2,2-dimethylpropane.
Oh, yes.
Okay, maybe, because then it would have been 1, 2, 3. Okay, then there's the 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Still not an option, but it was closer. Okay, so be careful, because sometimes they're going to put names in there that don't actually exist. Makes it more fun that way. Okay, 2.4. What is the product formed when ethanol and propanoic acid are mixed together in the presence of heat, concentrated sulfuric acid? That's esterification. The name is alcohol first, then the acid, so it's ethyl propanoate.
Propanoate.
It's A.
Yes.
A. Okay. Then, question 3. Now, question 3 apparently was also one of the ones not so nicely answered, but we did talk about these ones a little bit, okay? Remember, this is where it's a double bond oxygen, so it's a ketone and an aldehyde. You have to remember which goes where. This is where you've got to know where your functional groups are. The aldehyde is terminal. So the double bond to oxygen must be at the end of the chain for it to be an aldehyde, okay? This is the smallest aldehyde, which is methanol, okay, aldehyde. All right, it's the smallest one we can get. This, propanone, is the smallest ketone we can get. So when we look at the options here, we go, okay, well, number one has to be a ketone. So that means that can't be an option, that can't be an option. Now we look at the other options and we go, well, number two has to be an aldehyde. So we go, that's not an option, that's not an option, that's not an option, which means it's C, okay? And grade 12s, just as I've written on my sheet, that's what I'd expect you to do on your question paper. Remember, your question paper is yours. You will leave your exam venue with it probably, okay, unless your school wants to collect them for whatever reason, but it's after you've left. You can write all over it. I tell my learners this all the time. Write on your question paper. Rather write all of this nonsense on your question paper than on your answer sheet, okay? And in fact, when I do the memo, so when I get the prelim or the final and I've got to do a memo for myself, mine look like this, okay? And I've been teaching for a long time. Okay, got to quickly go on. For your unsaturated hydrocarbon, remember, unsaturated means got to have
it's double, triple bond.
a double or triple bond, okay? But so it can't be C, because it's only single bonds. But why can't it be A?
Because of the carbon branched in the oxygen.
Because of the oxygen.
Yeah, because
absolutely.
of the oxygen, yeah.
It's also the same reason why it can't be D.
Yes.
So it has to be B.
Yes.
Okay? And then this one, which cannot be an alkene.
I draw that out and then.
Okay? You
I
could.
I
Yeah.
found C.
It is C. Another way to remember this one
Okay.
is, remember, an alkene has to have the general formula CnH2n. So as long as it fits into that category, then it's fine. Because 2 times 2 is 4, so that one's fine. 2 times 3 is 6, that one's fine. So it can't be both of those. And 2 times 4 is 8. But drawing them out's also perfect.
Okay.
Okay, so it's this one. All right. Now, unfortunately, we are running out of time a little bit, but
Yeah.
I think I've got time to do about the revision, hey?
Yeah,
All
you
right.
do.
So, what do you need to do? Now, guys, this is brilliant. If you go to our Mindset online store, if you go to the Mindset website, you go to the online store, there is an absolutely amazing, amazing special on at the moment, and that is to do with our revision booklets. If you pre-order them now, you get a 10% discount, and they're going to come to you. Sorry, I'm just going to steal this from you. Packaged like this.
Yeah.
Full DVD set. I think it's 6 or 7 DVDs. I can't remember. 12. Okay. With the sheets that go with it. All the answers. It's like having us in your home. 10% discount. And the 250 Rand each. They are amazing. Go and pre-order them. You'll have them early next term. Okay. And I think that's all I have time for.
Oh,
Sorry.
yeah. Very interesting again. Pumi Shabangu is saying that was simple. I can see it really helps to analyze diagrams before attacking questions. Like you said, Tracy, it's very important to analyze the diagrams whenever you're given the question. All right, then, guys, we unfortunately have come to the end of today. Physical science revision class 4 now. Please join us at 2:30. At 2:30, we'll be doing geography. So please join us with us. Now, guys, let me quickly just announce the winner. It is Shikash. Congratulations to you. You are walking away with that nice CD. It is going to be coming to you. Thanking Soul Candy. Right now, guys, it is now time to say bye-bye. And please join us at 2:30. Bye-bye.
Bye.
In this case.
Okay.
No, it's added to an alkene, so it would actually turn it into an alkane
Okay.
because it's addition.
Yeah.
Okay, because it would break the bonds.
Yeah.
Okay. This is a nice one. Type of alcohol.
Oh, I struggled with this one.
Yeah, it's fine. first, remember we've got primary, secondary, tertiary
Yes,
alcohols,
yes,
right?
yeah.
So first thing we need to remember is where's the double bond oxygen in an aldehyde?
I said it's a secondary alcohol, so it's in the second carbon.
Because you think it's going to be in the second one.
Yeah.
But an aldehyde is actually defined by having it
Yes.
at the end.
Oh, so it's primary.
So you thought it was a ketone.
Yeah.
So no, it's fine. I like the thought process was correct.
Okay.
Because you thought it was a ketone, so then it would either be a secondary or it could have been a tertiary.
Yeah.
Okay, so it could have been either because it could be on the second or in the middle. Whereas they are specifically an aldehyde because there's only one option, which would make it a primary.
Primary.
Yeah. And I know, I still have to think twice about where the aldehyde and the ketone sit.
Yeah, same.
Yeah. The way to think about it is formaldehyde. You've heard of formaldehyde, hey?
Yeah.
That's what they used to preserve things for when things are dead. So when it's at the end of the chain, it's dead.
Nice.
So it's one way to think of it. I'm not sure it really works like that, and I'm probably going to get shot by somebody along the way, but it's okay. Anyway, there we go. Now, the series that has the carbonyl group in the middle,
Ester.
almost.
Esterification.
No. You're on the right track. You just got
Okay.
confused between carbonyl and carboxyl.
Carboxyl.
Esters are carboxyl
Okay.
because you're thinking of the double bond oxygen and the OH
Okay,
and the O
yeah.
in the middle, so you would be right. But the carbonyl is actually this one.
Oh.
So now, if the aldehyde had it at the end, which one would have it in the middle?
Sorry?
If the aldehyde has it at the end, the double
Okay.
bond oxygen, which one? Because we just spoke about them just now. This would be a ketone.
Ketone. Oh.
Yeah. Okay.
Okay, yeah.
You okay with that?
Yeah.
All right. All right. Then this one's nice. This is a nice because it's definition. Molecules that have the same molecular formula but different structural formula.
Structural isomer.
There we go. Isomers. Absolutely. And this penny's just having a whole moment. I just thought I'd share that with you. Okay. Anyway, the board doesn't like me, just in case you didn't know. Okay, so those are isomers. Those are definitions. So,
Yeah.
so we're okay with that. Okay. Now, after your one-word answer, I hate this earpiece, just so you know. We would then have to go on to the multiple choice. Now, what we're going to do, guys, is I'm not going to do the multiple choice with you right now because I want you to go to Curio. Now, some of you have already registered on your phones. That's great. You can also go to the Curio website, okay, for the mindset ones. The code is PS12 for today, okay, for Curio, PS12. All the multiple choice questions are there. There are 5 multiple choice. I'm just going to quickly go through them with you, but I'm not going to ask chemical properties. What would that be, Sufficient?
Homologous series.
Almost. That's the name of the general series. But
okay.
what is it that makes it say, what makes an alcohol an alcohol?
Functional group.
The functional group. So that's what they want, the functional group. If they wanted a homologous series, I hate that word, by the way, they would have asked for, the definition is a group of chemicals that have the same properties. Okay, that would be, but this is because they want the atoms that give its function.
Well, I would correct if I say it's the group of atoms with the same formula.
General formula.
General
Yes,
formula,
you would be.
yes.
Absolutely. Correct.
Okay.
Now, 1.2, the type. Now, guys, this is where we get it becomes a little bit hairy in normal questions because it says type of addition reaction where hydrogen halide is added to an alkene. Remember, if I just asked you for the type of reaction where a hydrogen halide is added to an alkene, we could just call it addition. Okay?
Yeah.
But now they want the full name
Yeah.
for the type of addition, not for those horrible long names. So
Yeah.
what would you call this one?
I said it's a hydrohaloalkene.
That's the type of compound we get when we're done.
Okay.
But now, if it's a type of addition, so then it would be the it's hydrohalogenation.
Oh, okay.
Yeah. So it's horrible words like halogenation, hydration, hydrogenation. The type of compound formed is would be a haloalkane. Alkene.
Hello, everybody, and welcome to Mindset Learn Extra. Thanking you for joining us live on our studio. It is channel 319. My name is Pumi, and joining us in studio today, it is Tracy. Hello, Tracy.
Hello, Pumi. How are you?
I'm good, thanks. How are you doing?
Good. It's a good place to be in the holidays, hey?
Yeah, it is, hey?
Wonderful. Well done for being here. I mean,
Yeah.
my platform's squeaking, but that's okay.
Yeah.
Anyway. Yes.
Anyway, we also have our mindsetter in studio today. It is Sfiso. Hello, Sfiso.
Hello, Tracy. Hello, Pumi. Hello, Mindsetters. My name is Fiso from Sebokeng in Zone 7, and I'm representing Esogwa Secondary School. I'm doing chemistry, not that good at it, but I'm sure Tracy will be helping me too much.
We're going to try. I'm sure it's not as bad as you think.
Not really, yeah, but I'll try.
All right, then, mindsetters, I'm sure that you also would love to see Tracy helping you out with organic chemistry today. Please do join us on our page. It is mindset.co.za/learn/winter school. You can always get our notes right over there. I mean, we are working on the notes the notes that we have on the page are the very same notes that we will be focusing on today. So please join us live right here on Mindset Learn Extra. One other interesting thing that we have for you guys at home is this competition sponsored by Soul Candy. Now, guys, this is what you have to do so that you can get this nice DVD. Okay, we are giving away. Okay, I'll tell you a little bit later what we are giving away, but it's one of these CDs right over here. So, guys, this is what you have to do. Jump on to mindset.co.za/learn/stop the clock. That is the name of the competition. You will have to choose any number between 0 and 9, and then you'll have this nice little form that you have to fill in where you can keep your guesses in it. But right now, guys, let's just get straight to learning and join us until we're done.
Okay, my turn. I think that's what Pumi was trying to say to me. Anyway, okay, so it's my turn, all right? And it's a very cool competition to make sure you get there. It's a good guess as to how many likes we have. Now, what we're going to do today is we're going to do organic chemistry. So the whole of today's lesson is focused on organic chemistry, which, yeah, if you like we saw, not so cool. Yeah. But yeah, it's okay.
I'll be all right.
You'll be okay.
Right, yeah.
Cool. All right. Guys, the thing with the organic chemistry is it's quite a big section in your exam. It can be up to 50 marks out of 150 in your chemistry, so it's a really important section. The nice thing is that all the questions are tending to be the same. So you can guarantee that you're going to get things like naming, drawing, isomers, and trends. The big thing with boiling point, melting point, all of those things, which, yeah, we know are there. But they're all the same. So what we're going to do is we're going to go through the sort of questions you can get. We're going to start with the one-word answers. The nice thing about the one-word answers is they tend to be more theory. So let's start with those. Okay. And the first thing they say, and remember with one word or term, it's exactly that. It can be a term or a single word. And they say to you, the first one is, an atom or group of atoms that gives an organic compound